Hello friends, welcome back to I Made Me Think, and let us continue our discussion on machine learning related Python programming. And in this session, let us discuss and understand the very important, very popular and very numerously used library called Numpy from Python. So let's get started. So this my source code for this particular session is available in this GitHub repository in this folder. So once you have time, just have a look and let's get started. So I'm using this Spider IDE with Python 3.6. So I'm importing NumPy library and numpy.matlib as npmatlib. So remember if you want to work on numpy.matlib, you need to import it separately as like this. So let's just execute this code and let's just start with our example. So generating matrix for given n into m, so rows into columns with given default values. So npmatlib.1, so I want to generate a matrix of 5 rows 6 columns with filled with ones or filled with 0. So let's run this code, control enter, and see what is the output. So if you see here, so generating matrix of n into m, so with this is filled with ones and this is filled with zeros. So np.matlib, so again once again here returns a matrix with 1 along with diagonal elements and the zeros elsewhere. So k is the start index to start the first one. So just run this, let's run this code once and see what is the output. So now if you see the new code here, if you see I want to have diagonal matrix. In this example I want to have diagonal matrix. So first of all, this is 5, this is number of rows into columns. So yeah, these ones are printed here, and in this example 5 8 3 and d type float. So this is all d type float. So d type is basically a data type of the matrix what you want to. So you can have integer, float, and there are other couple of options we'll see later. So now it has starting index, k is a start index, so start index is 3, so 0 1 2 3, and from there diagonal, so 1 and then next row next column and then next row next column, but it has limited number of rows and columns. It has stopped here. So I think it has 5 rows, so since we have specified 5 rows and 5 columns, 5 rows and 5 columns, and then so 5 rows and 8 columns here, so 5 rows and 8 columns. Okay, the 6, so 6 it will start and it will end at the last index. So generating identity matrix for given n into m with given default value. So default value is np.matlib, and just run this. And if you see here, so it has given an identity matrix with n into m combination, and this of type float, and all the values are 1. So generating the next code, generating identity matrix for given n to m with given default values. So here it is random value, and it is a values of it is a 3 by 3 matrix. So 3 by 3 matrix and random values. Generate a matrix of n into m with some random values. So again, this is the same example. Generating matrix from given array. So this is an array and np.matrix. So let's just run this code first. First of all, let me just clear the console first and run this code, and let us see what happens. So array now, and then np matrix array now, np. So generating matrix for a given array. So this is a So in earlier case it was generated a single an array inside an array with this is an NP array, and this has a number of elements, and in this case an NP matrix, so it has generated a matrix out of it. And now if you see NP dot matrix and again an array, so NP matrix is basically it will generate a matrix based on the value which you pass. Next example is as matrix from given array. So this is the array now. So basic matrix of NP array, so number of rows into number of columns. And now if I say as matrix, let's see what happens. So it has generated a matrix, 2D matrix out of this array. Now you can as matrix for given array, so you can consider it as matrix. So basically what happens is as matrix and as NP 2D array, so there's a difference. So if you see here it is array now is a 2D NP array, but when you say NP dot as matrix, so it will consider whatever is passed here as an matrix and not as an array. So let us run this code also and see. So again it has MATLAB generated with rows and columns filled with ones, and now it is considering it as a matrix and not as an array. Inner product, so these are some simple normal operations what we do when we use matrix. So inner product, so array normal and inner products we can do it using np dot inner first argument and second argument, which is happen to be the same. So let's see what is the inner product. So inner product is 1240. So there's a formula for inner product, but then how to do it using np array is this using np dot inner. Now so if I want to multiply two matrices, how can I do it? So 2D array 1, 2D array 2, and I want to just multiply this. So that is possible using np dot matmul, first argument, second argument. So let's just run this code first and see the output. So this was the first matrix, this was the first 2D array, this was the second 2D array, and then when we multiply this is the result. So matrix multiplication formula exists, but then if you want to do it using quickly using NP array, this is the matmul method is the one which we need to use. Then solving linear equations. So we will see this in little depth in subsequent sessions, but so basically using Numpy we can solve some linear equations. So normally we have equations, say with multiple variable and then multiple equations, and then we need to find out the actual values which is controlling this different equations. So let's say I have an equation called say 9a plus 1b plus minus 10c, so minus 8a, 5b and 0c and similar. So I have three different equations, and then I want to solve those equations. So this is my value, so this is my original value of ABC. Now how can I solve it using, if I don't know, let's say I don't know these values and I just know the equation. So how can you solve it using NP Numpy library and get these coefficients, A, B, triple A, triple B, triple C. So just put it as a matrix. So as a 2D array, so these are the coefficients we need to just put 9, 1 and minus 10, minus 8, minus 5 from second equation, 9, 3, 1 from the third equation, and then this is the equation becomes a 2D array, and then equation total. So we get the total here. We know the total here. So basically what we know is we know the equation. So 9x plus 1y minus 10z equal to some value. So these are the totals. So let's say the totals are my 541, 29 and 46. So that also you put it in 1D array, and then this is the np dot linear algorithm dot solve. So this is the method which NumPy has provided to solve a particular linear equation problem. So let's just run this and see if it is giving the correct output. So what we expect is a equal to 2, b equal to -9 and c equal to 55. Yeah, so 2, -9 and 55. So this is how we can solve linear equation very quickly using NumPy libraries. Now next example is a max. So basically, if you want to get the value of the maximum element in the entire array or in a column or in a row, so this is how you can get it. So let's just run this. So if you see here, so this is array max is 15, and then on vertical axis this is the one, and horizontal axis this is the one. So these are the different ways, these are the techniques to get the maximum or minimum value based on the row or column. Next example is flatten. So flatten method. So flatten is basically returns a copy of the array collapsed into one dimension. So basically it returns a copy of entire array into one direction. So even if the array is 2D or 3D, the flatten will convert it into a 1D array. So let's say when I run this code, and what happens, so I have run the code as I have called the flatten method. So now 2D arrays into 1D array, and then then I have taken the arg max on axis 1. So basically it has got me the maximum values for each column. Number sorting using NumPy. So basically first let's run this code, and this is the 2D array what I am considering here for my example. So this is d type, so d type data type, which is a float type of array. Now let us run this code line by line. np.sort does not change the original array. So now if you see, this is the original array was here. Now if I want to sort this array using some order, that is possible, but you need to call this np.sort, but that does not alter the original array. So this is the result will be just for the sake of for print statement, but it will not alter the original array. So when I sort it, what happens? So let us say this is sorting this first row. So first row is the minimum is -7 and then 4, 5, 6. So -7, 4, 5, 6 and etc. This rest of the examples. Let me just clear it. Yeah, now let us also run this code. So np.sort array to sort and axis equal to 0. So again this is sorting based on vertically. So vertically it has sorted in ascending order, and then axis 1, so it has sorted on horizontal axis. Now next example is sort on a row. So this is basically sorting on a particular row. So this has sorted only that particular row and everything else is same. Okay, I'm just printing this matrix, and now what I'm doing is so array dot name dot sort, so it will change the original array. So now if you see, I have called this method here array dot sort, and after that I'm just printing the values, so it will change the original array. So if I just print it, okay, so this has affected the original array, because the original array was used to start with 4 1 something. Now it is starting with ascending ordered. Clear the console and let's see the next example. So string sorting using numpy module. So let us say I have this array input string with this particular string elements. Now if I want to sort this array, because it is a string array, so what I need to do is I need to say list input string array sorted index. I need to get the indexes of all the elements, so I need to sort it. So okay, so I want to sort it based on the length of each element. So this is the formula. I need to first using this formula I need to get the list of indexes based on the length, and that store that index here, and then output string array which will be input string array argument sort. So this is not the simple sort, this is the argument sort, and based on the indexes. So this is basically reorganize the elements based on the indexes what we calculated here, and the index calculated here is basically the ascending order of list of indexes based on the length. So this is how you can sort uh, sort a string array based using numpy. So let's see the output again. Now if you see, the output is like it is sorted based on the this is the original string, this is the original array, and this is the sorted array which is based on the which is of type string, but it is sorted based on the length of individual elements. So the indices of elements greater than, so you can, the np dot where is another method where it acts like to find single or multiple elements based on some criteria. So where some criteria, so criteria is if any of the element is more than 5.5, just give me that element. So let's just run this code first and see the output. So this is the original array, and index of elements is greater than 5. So again it will give me the index, or it will return the arrays which are more than 5.5. All actual elements greater than 5. So this is the original array. These are the elements which are more than 5.5. So if you see, all these elements are more than 5.5, and shape of the resultant array is always 1D, because it will just extract the remaining the required elements. So that is why it is, although the input array is a 2D array, but then when you use the where clause, the resulting will be 1D array. So np dot mod. So mod is basically numpy extract the element out of an array with a condition. So earlier we used to use that where clause, now it is mod. So mod np extract 2.0 if it is equal to 0. So basically I'm just comparing it with some value, and if it is 0, then take an extraction condition np mod and then np extract. So let us run this code once and see the output. So in the resultant array, in this example using this mod, what is happening is, in the resultant array, the resultant array will be filled with true or false. So yeah, now if you see np mod extract based on some condition, and then fill with if it is equal to 0, then fill true or false. So if it is 2 0, otherwise it is false. So mod of so basically the thing is mod. So mod is it's a modulus. So if modulus of each element with 2.0, so if it is resultant is 0 or 1, it depends on that. So if it is 1, if the resultant is 0, then fill with true, or otherwise false. So this is the example where if you see different true and false elements, and then these are the elements which are extracted based on the condition. This is the condition. Let's run the next code. So in the next example we will see save array output to a .npy file. So here you can do it using np.save, and it will save it with this name, array save me, and this is the one. So, and you can load it using np.load from that npy array. Sometimes you need to save the array in a file, so this is how it will save it in an array. So let us see what happens. So it has saved it here and it has loaded it here. So after loading, this is the output. Now let's see next examples, next set of examples here. So again I'm importing some array here, np and numpy and some standard method. Now reshape. So reshape an array to n into m matrix. So this is the method you can do it using reshape. So this is the array now and reshaped 2D array. So array dot shape array dot now into 4 by 4. I wanted in 4 by 4. So let's run this code. And if you see now, the original array now was a 1D array. Now I have reshaped it into n into m. So reshaped 2D array will be this one. So now I'm just using a 2D matrix, a 2D array. Basically it has different type of elements, so different rows and different columns. So one of the element is in each row is a string. Append a row at the last. So if I want to append something at the end here at the end, so I can use it using np.append, but when I append it, it has to be in the same format. So same format, so string and then 1 2 3 4 5 numbers, so string and 5 numbers. And let's run this code. So earlier it started with row John, etc., April. Now it has inserted another row at the end. Insert a row at a given index. So I want to insert this. So this is the main matrix, and this is a new row I want to insert, but I want to insert it at index 3. So let us run this code and see what is the output. So it has inserted the additional row starting for Ted. So 0 1 2 and third place it has inserted that row. Insert a column at a given index. So if I want to insert a column, so let's say this is a simple example of student and the number of the marks or some number. So if I want to insert a particular column somewhere here or somewhere here, I can do it. So np.insert at position number 1, and this is the column I want to insert. The column contents will be a string, which is constant string here if you see here. So if you see at index 1, it has inserted that column. Let's see the next. Okay, so the deleting a row. So if I want to delete a row at a particular index, so I can do it using matrix student row number 2. So that additional of added element. So it started with Roy, John, Dave, Ted. So Roy, John, Dave. So Dev is deleted here. So if you see John, Dev, Ted. So John, there's no Dev and there's a Ted. So at index second row, index with count 2 to be removed. Delete multiple rows. So after deleting a row at given indexes, so I want to delete from row number 0 to 1. So if you see the row number 0 1 2 is removed, 0 and 1 is removed, so 2 rows are removed and the rest is remain the same. Now next example, delete a column, so again delete a column, np.delete, and you can specify different criteria. Delete multiple columns, again you can say different, you can do it using slice different columns, you can run it on your own. Shape is a tuple, so now let's run this code. So this is the main matrix with some rows and columns, and then when I want to get the shape, so shape is n into m, but then that shape will be a tuple, which cannot be modified because tuples cannot be modified. So if you see, this 4 into 6 is a tuple because rows and columns are fixed. Okay, now this is an example. So create an array of 2 by 2, create an array of n into m filled with zeros or ones, and then filled with random. So create an array of 3 into 2 filled with random numbers, 18 rows and 5 columns with random. So you can have different methods which through which you can run different random numbers. You can generate random number arrays. np.full 5 into 6 with 22. So create an array of n into m and fill with custom value. So it will fill it with number 22. So let us just run this once and see the output. And then what is the output here? Yeah, so everything is filled with 22 here. So np.full, and again I want to fill it with some float value or whatever value. So I matrix, identity matrix is generated using I method. So let's just run it first, and now it has generated an identity matrix here. Yeah, so number 6 by 6, and then if you see, all the values are 1 here and all others are 0. So np empty like error customer int. So in this empty like method, what it will do is it will create an array which will be empty, but it will be like this particular whatever sub array variable we pass it here. So creates a matrix, creates an array basically, copying the given matrix, but it will be empty. So let's run this. And then if you run this, it will be an empty matrix, and it will be of size and shape of this particular array. So this particular array is not empty. You see, this particular array is not empty, but so it has copied it from this customer int. So this is array, this is not empty, so it is converted that into zeros. So these are some normal metrics for other examples considered. So okay, so dot product, so dot product is done using dot method. So yeah, this is the dot product. Vector product is done using v dot, and dot product is done using dot method. Let's run this and see the output. Okay, so dot product and vector product was successful. So dot product will return the matrix of size which is for the elements considered, and vector product is basically sum of all the multiplications. So there's a formula, but if you want to do using Numpy, we can do it using these methods. So if you want to do sum of all the elements using that can be done using sum method. Transpose of a matrix, so that is very simple, dot capital T, which will give you the transpose of the matrix. So just run this code and see if there is any error. some text, no keyboard or no keyword arguments. Okay, now add a child array to each parent array. So now basically what we're doing is so this is the basic array which is having some elements, and we'll create an empty with like this, and in this way. So yeah, so this is adding a child array into sub array. So let us run this first and see the output and then explain. So this is the basic array which is having 10 elements, and then new array is also same. So and this is the additional child array with elements which we want to add to this base array. And so when I do this operation, so basically it will add this element to all the elements. So 5 plus 1, 5 plus 3, 5 plus 5. So if you see, so everything is added plus 5, and all the this second column is added with 8. So everything is 8. So basically what we are doing is adding a child array into a parent array. Now declaring array as intended d type. So d type is basically data type, so of the np array what we want to consider for our testing purpose or for any development purpose. So if you don't specify exclusively, it will take off integer, I think, but if you want to specify, you can do it using this d type equal to. So d type equal to uint, int 8, int 16, int 32, and it can be of type complex or float or others or uint. So that is what we will see here. So let's just run this code and see the output. So here if you see unsigned int, d type is int, d type is int 8, d type is int 16, int 32. So we can have different maximum minimum values, but this is how we can do it. So in order to get the shape of the NP array, we can use it using method called shape. So this is again revel. So revel is basically np.revel, that is flattened 1D arrays. It will give you it will return a 1D array. Reshape will not change the original array. Matrix student dot reshape. So when you say reshape, it will just rearrange the values from the parent array, but it will not change it. So let's just run this code once. Resize will change the original array permanently. Reshape, resize, there are two different things. So let us run this first and see the output. So matrix student travel, so it's a flattened array which is a 1D array. If you see, this is all 1D array. Reshape will not change the original array. So matrix student reshape to 8 by 3. So it has reshaped that to 8 rows and 3 columns. Reshape and resize. So resize will change the original array permanently. So resize into 8 into 3. So again the output will be same, but it will change the existing array permanently. Okay, stacking of different types of array. So if you want to say combine two arrays, so basically add one array at the end of second array, or add one array on the right hand side of second array, or things like that. So that can be done using different methods here. So let first just prepare the data, and then so first 4 by 3 here, and then second 4 by 3. I'm just taking it here. Run this code and then run this array, run this. So just print the 4 by 3 arrays. So it has printed the 4 by 3 array here with this. So we have done a data setup here, and now vertical stacking. So column count should match. So when you want to do vertical stacking, so column count should match. So what I'm doing it here is np.v stack, and then stack this to this. Similarly I can do horizontal stack, so h stack this to this, and then give this output. Let us run this first and see the output. So 4 by 3, second 4 by 3 vertical stacking. So if you see vertical stacking, so it was first 2D array was having 0, 12, and it is 4, 8. So 0, 12, 4, 8. So this is vertical stacking. So remember, when you stack vertically, the number of columns should match. And then horizontal stacking, so if you see 0, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, true 3, and then 4, 5, false 7. So 4, 5, false 7. So it has done a horizontal stacking. So when you do a horizontal stacking, row count should match. So this is how we can do stacking operation. And then concatenate, so you can also do concatenate. So concatenate based on axis x or axis y. So again, this is a kind of vertical and horizontal stacking, but with different methods. So if I run this and see the output, yeah, so concatenate vertically, concatenate horizontally, that is also possible. Places arrays as common in another as column in another array. So np.column stack. So this is again a simple example where I'm doing a column by column. So let's just run this first. So again, so this is a 1D array. This is a 1D array, and then I want to have a array which is stacked of two 1D arrays but as a column. So now when I run this code, and if you see, these are all 1D array, and these are like this is a one row. This is one row. Now if I want to convert this row to column and then stack it as a column, this is the way. So let's just run this code, and now if you see, column stack, column 1, column 2, and then c1 c2 side by side. So this is how you get it, but you get it as a column. So that is again possible. Add array element using plus symbol. So again you can do some different techniques like add 2D, add this another row using plus symbol to this. So there are different things what we can do. Just run this code and see if there is any error. Yeah, there's no error, so you can do it. So get the selected slice of matrix elements. Again, you can do different uh, substring or sub elements of 2D array or 2D matrix. So starting index, ending index, and then some specific criteria. So let us just run this code once and see. So this is the original array, 2D array, and then get selected slice of matrix elements. So you can get selected slice of a, so for example, row 1 to row 3. So row 1 to row 3 minus 1, and column 2 to column 3. So column 2 to column 3. So 22, 23, 32, 33. This is how we get it. So row 0 to row 3, and from column 2 to column 3. So different options what we can specify it here. So this is how you can do a get a sub slice, get a selected slice of matrix or 2D array elements. So again, if you want to, we have seen array stacking. Now if you want to split it using based on horizontal axis or vertical axis, you can do using split method. So HS split and VS split, and based on some different criteria. Simple array split. So 1D array, then also you can split. So array underscore split and some index and some column, that you can also do. So same array with multiple names. So this is basically a copying method. So if you see array 2 equal to array 1, so I have assigned uh, this array to this array, array 1 to array 2. So both the IDs will remain the same because they are pointing to technically the same array. Then again copying the array, so array dot view will give you a temporary view, but it will not alter the original array. So if you see now here, I've assigned a view of array 1 to array 3, but then when I reshape array 1 to different combination, let's see what happens. So a shape view doesn't change, even the shape of the original is changed. Now again using dot copy method, so which creates a fresh copy of the object. So in your spare time, please try out different examples and try to understand this. There are many methods you can do. So if you have any comments, please put it in the comment section, and please like, comment and share my YouTube channel. Thanks for watching.